Next up, we have Dr. Leanne Clevenger, which is SI2's newest employee.
I want to introduce myself. I'm Leanne Clevenger, software engineer and data scientist at SI2. And one of my focus areas is artificial intelligence and machine learning. How can we tell if this is the right time for production design automation to take advantage of artificial intelligence and machine learning? Well, it turns out the software tools are in place today for any member company to use OpenAccess to find out. And as Jerry just told us, we have the Open Standards Coalition so that we can work together on common goals. So a popular example of deep learning is the work that was done by Andrew Ng at Stanford and Jeff Dean at Google to learn what a cat is without prior knowledge from internet images. And that was done in 2012. And now between then and now, you can find hundreds of tutorials on the machine learning concepts that have just really grown between now and then. But today we're going to discuss using OpenAccess to drive deep learning. And to put this in perspective, 7 years is about the same length of time that took me to become a long-distance runner. Back in 2012, I ran my first 5K, and Monday I'm qualified for the Boston Marathon. So it's a lot of progress is possible in 7 years. So artificial intelligence and machine learning are really broad fields, and for SI2, I'm narrowing our goals down to really focus on design automation applications for AI and machine learning. So from the outside going in, looking at it from a design automation perspective, artificial intelligence would be a system that's going to make decisions like an expert designer would. And then machine learning, these are just a few of the examples, but there can be, for example, taking the yield data from the foundries and using that for an analysis, for example, using standard Python libraries. For deep learning, a lot of our work is visual, both TEM pictures, as shown here, or layout, and that can be analyzed using deep learning algorithms. And then reinforcement learning is making educated guesses that get closer to the answer, very much like a human would make decisions. So all of these actions in design automation can enable hardware design that enable AI. For example, what the Mythic folks were talking about, analog FPGAs, neomorphic computing, phase change memory. So what we're talking about doing is using the software to basically enable and design the hardware that could in turn be used for AI applications. Right now, today, the software platform is compatible between OpenAccess and the popular AI platforms. Python 3.6 and 3.7 are supported in the OpenAccess and OA script, the latest versions. They also support TensorFlow and PyTorch and the popular Python packages. So right now, all of these are available today, and in fact, we have them installed and running at SI2. So all of this is available to start on projects. So I'm ready to work with any interested member companies that want to leverage the open standards model that Jerry was talking about and incubate some new ideas for artificial intelligence with OpenAccess. Some examples would be defining a flow for how you would train on open access data, reading that data for inference, and then, for example, back annotating that. You could have an idea of a virtual checker using deep learning with a number of different visual areas, or use reinforcement learning to train a virtual designer. And this could be run on, for example, on GPUs on the cloud, or looking at some dedicated AI chips that run at the edge. So there's a real matrix of possibilities that we could look at. So we're looking for a company to champion an open standards working group in this area. The SI2 model that Jerry had described, especially, one good example is the low power working group, also the OA XPOP working group, the OA script group, is to have a member chair and volunteers working together. As a group, we define a proposal or more than one proposal, and there are tools in place to either not only discuss it, but to actually put together a working prototype, for example, of a design flow with OpenAccess that works with AI. And once a prototype is available, then that would be available to members of the group to take back to their companies to further develop their own, with their own IP, develop their own solutions. I want to give an opportunity to all of you to participate with us in this. I'm looking forward to a successful run in Boston on Monday, and also look forward to working with all of you to build on the current open access and AI platform for your production design automation. Any comments or questions?
Hey, it's Thala McMythic. There's an interesting kind of concept in relation to determinism with AI. Obviously, you need your algorithms and your code, your hardware to be very deterministic, but then the outputs of an AI algorithm have a certain probabilistic element. And that kind of, it seems to interleave here as well, in that some of the visual recognition in relation to quality, some of the chip micrographs you were showing, those are probabilistic things as well. So I just wonder if you'd care to comment about that intermingling of determinism and non-determinism in all of this.
Yeah, it's an important consideration when the customers, whether it's the designers or the ultimately the people getting the chips, are used to what they consider definite. This answer is right and this answer is wrong. I know from my experience in circuit simulation that the device models have a variability built into them, and in general, design tools and simulators have a variability built into them as well. So I think a lot of this has to do with communication, that it's not new that your tools are not perfect. And I think we just need to quantify that, really communicate that. And also relate that to say, okay, this is how, for a simple example, this is how this analysis would be done by standard tools. This is how this analysis is done in using machine learning, and compare the results and compare the probabilities.
Great, thank you.
Thank you, Leanne. Great presentation.
Thanks everyone.